Thanks for joining me. Today we're going to talk about when variables are related. What do we call that relationship? One way we can describe that is with a correlation. So when we've got two variables that we're examining, and are these variables tied together in some way, or do they occur together in a particular pattern, we say that these things are correlated. Now break down that word. Two parts of that word are co, meaning together, and related, meaning obviously related. So we can think that these two things vary together. They might both increase together or decrease together, or one might increase as the other decreases. So we say things are correlated. You might also hear correlations being referred to as associations between variables. Relationships. There is a relationship between crime and socioeconomic status. Or that two variables co-vary, or there is a co-variation. When you get to statistics, you'll be able to understand these terms are all the same, but we use them slightly differently when we talk about running stats or just general relationships. Now that idea of a correlation is a bit abstract. We are able to see it, but only when we put our data into a spreadsheet, into a graph, can we show a pattern visually. So this mini lecture is going to go over when we can identify a correlation and what that looks like on a graph. Now let's say if I'm trying to look at a relationship between the two variables, assaults and time. So you can see on this graph here, on my y-axis, I've got number of assaults, and on my x-axis, I've got the year, okay? If I just put data points in the graph like this, can I see that there is a predictable relationship? That is it going all in one direction, or is it not? Are the data points all over the place? We might not be able to see something on a graph like this, but we'll talk about examples when we can. Now, the idea of correlation is very similar to these concepts as well. Prediction. And this is where things become really useful in social science. So if we say low educational attainment can predict if someone will have encounters in the justice system, we want to be pretty sure that there's a relationship that exists between these two variables. We can also talk about the term generalization. When we say, generally, men commit more violent crimes than women, it's because there's a demonstrated relationship between the two variables. We might also use the terms effect strength or effect size. So how big is the relationship we're talking about? If it's a small correlation, then there's not a whole lot of power in it. But the bigger the correlation, pretty good predictive power we're seeing, or a big effect size. Now, we can indicate the strength of a correlation with what we call a correlation coefficient. So this is a number that's calculated between 1 and 0, or more precisely, between -1 and +1. The closer our correlation coefficient gets to 0 on either the positive or the negative side, then that means we are not seeing any correlation between our variables. So if we might look at something like eye color and weight, are these two variables related? I would say we'd probably have a very low correlation coefficient, maybe at a 0.05. Now that means we don't have any ability to predict how much someone weighs based off the eye color they have. Those are just two arbitrary variables that don't vary together. However, the closer our correlation coefficient is to the number 1 or the negative 1, then we say that that is a perfect correlation. That means we've got the perfect ability to predict what the value of x is based off the value of y. Now, when I say it's perfect, I mean It's 100% accurate. That means there is no prediction error at all. So that wouldn't necessarily be a hypothesis. That would be something that is a truth, okay? Now, what about the negative and the positive? The negative and the positive in front of the correlation coefficient indicate which direction the correlation is. Now, if it's a positive number, that means we've got a positive correlation coefficient and there is a positive correlation. Obviously, if we've got a negative number like negative 0.8, then we've got a negative correlation. What's the difference between these two? Obviously, if we've got 0, that means there is no correlation. And the closer your correlation coefficient gets to 0, the more sure you are there is absolutely no relationship between your two variables, like eye color and weight. Now, here's an example of two variables that are positively correlated. Individuals with high income tend to have higher rates of white-collar crime. So our two variables in this situation would be income and rates of white-collar crime. And because we say these two things vary together, they're traveling in the same direction together, then they would be positively correlated. A negative correlation might look like this. Individuals with high levels of income tend to have lower rates of violent crime. Now, that means as 1 is increasing, so my variable of income, as it increases, my variable of violent crime is going to decrease. So because 1 is going up and the other is going down, I call this an inverse relationship. And that relationship is reflected by a negative correlation. Let's continue. A correlation coefficient of +1 or -1 means we've got that perfect correlation. That means if I know the value of one of the variables, then I can predict with 100% accuracy the value of another variable. There is no predictor error, okay? So if every time I hit an 8 for variable A, then I'm going to hit a 10 on variable B. That would be a perfect correlation. Now, this is also called a deterministic relationship or a deterministic pattern. And that means 100% of the time, when A equals 8, B equals 10. Now, you can probably imagine in social science, there are hardly any deterministic relationships or any variables that we can look at the relationship as 100% predictor. Here's an example though. Let's say we have that variable 1 in the first column and the variable 2 in our second column. As you can see, across the board, every time variable 1 is a number, like 1, variable 2, the exact same number. Every time it's a 7, variable 2 is a 7. So based on what we see here, can we predict what that question mark will be if variable 1 is an 8? If you said 8, you're correct. So this means these two variables are perfectly correlated. Now this could be something like the exercises you perform and the number of calories you burn, okay? So we might be able to perfectly predict those sorts of things. But when it comes to personalities and criminal behavior, not quite so easy. Let's have a look here. Same sort of scenario, two variables, and we've got numbers in each variable column. Every time variable 1 is a 1, variable 2 is a 3, which is 2 more. Every time it's a 3, variable 2 is a 5. Again, I'm seeing an increase of 2 for each data point in variable 1. So if I have variable number 1 as an 8, what can we predict that question mark will be in variable number 2? You said 10, you're correct. So again, this is a highly correlated variable, probably up near the 1, because that means we've got perfect prediction. There is no predictor error here because we can see these two things are continuously increasing and continuously moving along the same path. but this is more like the data we'd be likely to find in social science. So if we can look at the same sort of graph, phenomenon or variable 1 and variable 2, we're not seeing a perfect split down the middle here, especially if we look at the indicators for the number 3. In column 1, for variable 1, if you get a number 3, in column 2, you're going to see a 5.1, and then a second time, a 4.9, and further down the scale, we see a 5.2. So we know it's not 100% accurate, but we can definitely determine there is a relationship here. Now, can we predict what the number 8 might be, or what the question mark might be if there's a number 8 in variable number 1? Well, we could say we think it would be about 10. We cannot say with 100% accuracy, all right? Now, can you see a pattern in these values? An easy way to tell is if we look at the same value throughout column number 1. I see 3 different times when column number 1 has come up with a 3. Let's look at the corresponding values in the variable number 2. I see a 1, I see a 9, and I see a 5. Does that appear to you that every time we have a value of 3 from variable number 1, that we get the same value for variable number 2? It looks pretty all over the place to me. So in my opinion, I would say I don't think these two variables are related. They're not moving in a similar direction or in an inverted direction. So with confidence, could we predict what that question mark would be in variable number 2's column? I don't think we can. It looks pretty all over the board. And if we put this on a graph, you might be able to see visually, oh, I can't see a relationship happening here. Now, when I talk about putting things in a graph, this is how we can visualize or graphically display our correlations. We can do this a couple of different ways. One, as a diagram. So I've got 2 variables, let's call them X and Y. Now notice they're in their same, or they're in different bubbles, a bubble for X and a bubble for Y. Then they're joined by a bidirectional arrow, okay? It's not a unidirectional arrow like we see in causal relationships. This has 2 directions to it, so we call it a bidirectional. That means X and Y are related, but I cannot say with certainty that one is changing the other. All I know is they're changing at similar rates, okay? I might be able to see a correlation in a table, just like we were previously reviewing. And here's another one. If I've got an experimental group and a control group, and I can see numbers on a table. Okay, well, I can see things as we're getting a mark here. I see fewer marks over here, okay? We could display it numerically in a table. And another way we can display correlations visually is on a scatter plot or on an X and Y graph. You'll get lots of practice doing this in your statistics class. Let's show you a couple of examples now. Now, how would I demonstrate a negative association? So like I said, correlations can either be positive from 0 to 1, or they can be negative from -1 to up to 0. If these 2 variables have a negative correlation or a negative relationship, then this is how I would display it as a diagram. I might have socioeconomic status is related to burglary or becoming a victim of burglary. As your socioeconomic status rises, your chances of becoming victim of burglary decrease. So as one is increasing, the other is decreasing. And we would say that's a negative or an inverse relationship. As one goes up, the other goes down. On a graph, it would look like this. So you can see here as the levels on the y-axis are high, the levels on the x-axis are low. And as we move along the x-axis, they're going to become low on the y-axis. So it's a downward slope, and we would say that is a negative correlation. Positive correlation, we're just flipping the script. So as we can see on this graph, when levels are low on the y-axis and on the x-axis, they're very similar. As we travel up the scale, we can see that line going in an upward direction, demonstrating a positive relationship between these two variables. In a table, it might look like this. As x is low, y is high. And as we travel down the scale, they change. That would be our negative correlation or our inverse relationship. Positive, as one starts low, the other starts low, and they change at similar rates, going in the same direction. Positive. Now, what if we had points like this? So this is what we would call a scatter plot, where we put all of our data points on a single graph. By looking at these points, can you, with any certainty, draw a line, either upwards or downwards, that includes most of these points? I don't think I can. If we see a graph like this, we can say we don't think that there is a correlation between x and y because they're not grouped around similar numbers. So as x is increasing, is y decreasing? No, it seems pretty all over the place. So this is where we would say, I can't make a line that touches most of those points, so it's likely a zero correlation or no relationship between these variables. And that's what it would look like on the graph. However, if I had points on a graph that lined up like this, if I could draw a line that touched most of those points or came close to touching most of the points in a straight line, I would say that I've got a correlation between the variables, and it is positive because it's moving in an upward direction. So as x is low, y is low, and as x gets higher, so does y, or the values. What if we see something like this? Again, we see the points on a graph, and we can draw a line that touches or is very close to touching most of these data points. We would say this is a negative correlation. Now, the better that line touches each point, the closer it is to a perfect or a 1 or -1 correlation coefficient. So thank you for joining me today. I hope you have a really good idea about what correlations are. Hope to see you next time.